Hi, welcome to the session. Today we are going to discuss about Bresenham's line algorithm. This algorithm is developed by Bresenham, which is used to generate an accurate and efficient raster line. Usually our monitor can be taken as a x and y in the sense that is the vertical axis shows the scan line position, horizontal axis identify the scan pixel columns. To draw the line, 2 points are needed as an input, starting point and ending point. Starting point can be represented as xs, ys or x1, y1. Endpoint can be represented as xe, ye or x2, y2. If our current plotted pixel is 1, 2 in the sense, our next pixel of the line may be either 2, 2 or 2, 3. There are only two possibilities. So this is the problem going to be solved by the Bresenham's line algorithm. Consider the line is positive slope, that means the slope m is less than 1. The pixel positions are determined by sampling at unit x interval. So if the positive slope in the sense exactly the next position of the x coordinate is going to be increased by 1. So if the current pixel is 1 in the sense, for the next pixel exactly we can fix as a 2. Now we have to determine whether the y position is same or otherwise we have to move forward one step. If the xk, yk is the current position which is displayed right now, the next position may be xk plus 1, yk or xk plus 1, yk plus 1. Suppose the point may be crossed a particular point as a y in the sense, we have to calculate the distance between yk and yk plus 1 based on the particular crossed position. So actual point is, take it as a y in the sense, for our limitation either we may choose yk or yk plus 1. So we have to calculate the distance d2 equal to yk plus 1 minus y and d1 equal to y minus yk. So which is lowest value we can able to choose. If the yk is the nearest pixel in the sense, we can able to use yk. If the yk plus 1 is the nearest to the y in the sense, we have to use the yk plus 1 as a coordinate value. Next, here I give the Bresenham's line algorithm for the positive slope. For the first step, input the two line endpoints and start the left end point in x0, y0. Load the x0, y0 into the frame buffer, that is plot the very first point on the monitor. In the third step, we have to calculate some constant values del x, del y, 2 del x, 2 del y and 2 del y minus 2 del x, and finally we want to identify the initial decision parameters p0 based on the formula 2 del y minus del x. And the fourth step is used for to find the next position. This fourth step will be repeatedly executed del x time. Now we are moving to the one example problem to explain the algorithm. The problem is to illustrate the Bresenham's line algorithm and digitize the line with endpoint 20, 10 and 30, 18. First we have to identify whether the given line is positive slope or not. So we have to find the slope. Here the slope is calculated. The slope value is 0.1, that is less than 1. So it is the positive slope. Next we move to the third step. So we calculate the constant values first, and then we calculate the decision parameters. First we find the del x. Del x means this is the distance between the x coordinates. The del x equal to 10 and del y equal to 8. 2 del x is 20, 2 del y is 16, and the constant 2 del y minus 2 del x equal to minus 4. And next we need to find the initial decision parameter p naught. P naught is calculated based on the formula 2 del y minus del x. So the initial decision parameter is 6. Next, the fourth step. The k represents the number of iterations of the fourth step. Initially the k is 0. P naught is already calculated, so the P naught value is 6. 6 is the greater than 0. So in the fourth step we know that if pk is less than 0, we go for the then part. Next position is xk plus 1 and yk, and we have to calculate the next decision parameter pk plus 1 equal to pk plus 2 del y. If it is the else portion, in the sense next position is xk plus 1 comma yk plus 1, and we have to calculate the pk plus 1 equal to pk plus 2 del y minus 2 del x. Here the p naught is 6, so it is the greater than 0, so we have to choose the else part. So the current pixel is 20 comma 10, so the x's surely go to the next position 21, and the y position also move forward, so the next position is 21 comma 11, and the next decision parameter pk plus 1, that is p1 equal to 2. For the next iteration of the fourth step, 2 is greater than 0, so the x position and y position is going to be incremented by 1, so 22 comma 12, and the next decision parameter is calculated in the else part. So the p2 is getting minus 2. Minus 2 is the less than 0. In the fourth step it is satisfy the if part, so the next position the y should not be changed, so the next position is 23 comma 12, and the next decision parameter is calculated, that is p3. P3 is 14. For the next iteration the 14 is greater than 0, x and y coordinates are added by 1, so the next position is 24 comma 13, and the p4 is calculated as 10, so the 10 is greater than 0, so the x and y coordinates are going increased by 1, so 25 comma 14 is the next position, and the p5 is calculated as 6, so 6 is greater than 0, so the next position is 26 comma 15. Next decision parameter is calculated p6. P6 is equal to 2, so the iteration 7. 2 is greater than 0, so the next position is 27 comma 16. The next decision parameter p7 equal to minus 2. Minus 2 is less than 0, so the y coordinate value does not change, so the next position is 22 comma 16, and the next decision parameter p8 equal to 14, so the 14 is greater than 0, so x and y values both are incremented by 1, so 29 comma 17 is the next position, and the next decision parameter p9 is calculated as 10, so it is a greater than 0, so the x and y values are increment by 1, so 30 comma 18. So this is the last endpoint of the line. So totally the fourth step is repeated 10 times to achieve the all the intermediate points. So the final intermediate points are listed here. If it can be plotted on the monitor in the sense, we will achieve this kind of result. Thank you.